So in our last chapter, we have done the vectors. We write the vectors as x, y, z coordinates, and also we have done the adding, subtracting, multiplying, dot product, cross product, and the applications of vectors. And in this chapter, we are going to see how we can write equations of a line and equations of a plane in 2 dimensions or 3 dimensions space. So today's lesson, we are going to see the equation of a line, but in different forms. So parametric and the vector equations of a line in 2 dimensions. So we want to connect what we have learned before. We have learned before is y equals mx plus b. So this equation is our slope is m and y-intercept. So it is, we have a point y-intercept. Then if we have the slope, we are able to just sub in the slope and the y-intercept. We can have the equation of the line. So similar to this one, we must have a point on the line. Then we must have a slope, the direction vectors. Then if we have both, we are able to find the equation of the line. So we are going to see one example. Find the direction vector from 2 points that is on the line. So from A to B, we know the vectors. We could write it as BA or AB. It doesn't matter. If it's from A to B, then it's OB, second letter, minus the first letter. So we have second letter is 3, negative 7, take away the first letter, 4, negative 5. This is the vectors from origin to the point A. Then just subtract the x, subtract the y. Accordingly, we have negative 1 and negative 2. So this is a direction vectors if a line passes through these 2 points. And question B, what's the slope of any line with a direction vector d? So this one is kind of this delta x, this is delta y, so the slope will be the rise over run. And the rise over run will be the difference of y divided by difference of x. So it's just your direction vectors y, x divide. So the slope is 2. So this is we connect with a direction vector with a slope. And after that, we are going to see. So if we have point A is 4, negative 5 here, and 3, negative 7 here, the equation of this line, we could write it as 1 point and plus direction vector. So this is point A. Then we just add any vectors to that. You will find another point. So this is OB. This is OA, sorry. And plus the direction vector, we could write it as a number times the direction vector. Then we could just add any vectors on this direction, then tail height from here to here. You will find any points on this line, and that is the equation of the line. So we continue to see how we can write the equation of a line out. If we have a point x0, y0, and we have the direction d, what we could write is, we write this one as our vectors are 0. Then the equation of that line is r, then r0 plus td. So it's similar with our y equals xm. This is our b. Okay, so we have the r0, so this is a point on the line. This is our r0, and the direction is any of the t times d. So this is td, then this is another point on this line. So this is kind of xy point equals this vectors plus the t times d. Then you can generate any points on this line. So this is our equation of the line in vector form. So r0 is a point on the line, and d is our direction vector. So we know how to write a vector equation out. We are going to practice. So example 2. State vector equation. So this is our first equation. You need to know the form of it. So pass through 2 points. And what are 2 other points on the line? So first thing, we have to write the equation of the vector equation of a line. We know it is vectors on the line equals points on the line plus this is kind of like any t value times the direction vector. Then we could generate the whole line. T will be any real numbers. Okay, so the direction vector, we could write it as from P to Q or backward. It doesn't matter. The reason is T could be positive or negative. If T negative, these two kind of flipped. So PQ, it means Q minus P. Then we sub in this one. Q minus P give us 3. Q minus P is negative 6. If you have negative 3, positive 6, it's correct. Then we are going to write the vector equation out. So we sub in any of these points. Both will give you the same line. So we could just pick for 1 the point P. This is OP, then plus T. This is X variable. So in our vector equation, we need to have the vector R, and also we need to have the T left. We need to have 2 variables here. Then we put the direction vector 3, negative 6 here. Then it's done. Then we put T belongs all real numbers. So it's kind of, you have 2 parts. We need to indicate T could be any numbers. Okay, so this is first part, then other 2 points. And we know that T could be any numbers, so we could just pick T equals maybe not negative, not 1. The reason is we put 1 here, you will find out it is Q, so it's not 2 other numbers. So we may pick T equals 2. If T equals 0, it is P, point P. So we don't want T equals 0, point P, or T equals 1, point Q there. We need other numbers. So you could pick T equals 0.1, but we don't want to have the decimals. So we want to pick integer. So T equals 2, we sub in. We have R equals 4, 1 plus 2 times 3, negative 6. Then we just expand. We have 4, 1 plus 6, negative 12. Then x plus x, y plus y, we have 10, negative 11. This is the 3rd point on the line. Then we could find another one. We could find T equals 3. So we just base on the for 1, then plus 3 times 3 negative 6. Then do the calculation. We are able to, based on the 2, we just add 3 negative 6 here. You will have 13 negative 17. So keep going, right run. 10 plus 3, negative 11 plus negative 6. Because we have 2, we just need to add another 3 negative 6 here to get the fourth point. Then you will see that this equation, vector equation of a line, works. You can find the point on the line. Then we continue to practice more about the vector equation. Okay, so this one, vector equation of a line is given. Then it asks you, are the lines represented by the following vector equations coincident? It means they are the same line. So are they same line? So in order to prove they are the same directions, then we need to have the direction vectors connected. So we could use a cross product, but we also could use another method. So we are going to see that if they are same, so we are going to expand it and find the x and y coordinates. So 3 plus 2s is our x coordinate, and for the y coordinate is 4. S times negative 1 is minus s, and this one is negative 9 plus 6 times negative t. T times negative 6 is negative 6t, and y coordinate is 10 plus 3 times t. If they are the same line, it means we should have the x coordinate, y coordinate equal. So 3 plus 2s equals negative 9 minus 6t. 4 minus s equals 10 plus 3t. So we have two lines. We want to find the point of intersection. If they have infinite number of points of intersection, means they are same line. If they have no solutions, it means they are parallel. If they are only one solutions, then it means they are not parallel. Okay, so this is not coincident, not parallel. Okay, so this one, 0 solution. This is 1 solution. So equation 1, equation 2. And in order to solve this equation, we could use a elimination method or substitution method. Which method you want, you could use it. So this one, we want to use elimination method. So 2s, negative s. We want to change the two numbers at front of one variable same. So we want to times 2. So equation 2 times 2. Then we are going to have 8 minus 2s equals 20 plus 6t. This is our equation 3. Then we copy the equation 1 below it to align them very well. Then you will see negative 2s, positive 2s. If we add these two equation 1, equation 3 together, we can get rid of the s. So add together we have 11s. Minus 2s plus 2s is 0. This is what we want. 20 minus 9 give us 11. Then plus 60 minus 60 is 0. So 11 equals 11, always true. What it means, st, any s or t values, any values of s and t will give you these two lines same. So any values of s and t will make the two equations true. And what it means is the point. You change the S and T, you will get all the points on the two lines. So you have infinite solutions for these two lines. So therefore, we are going to write, okay, infinite solutions, infinite point of intersection. The two lines are same line, coincident. Okay, so this is how we prove it. If these two not equal, it means these two parallel. If you have one variable left, then you are able to find only for the particular S and T, you have one point of intersection. So this is a first method is just let x coordinate, y coordinate same to find the point of intersection, and we find that for any values of S and T, these two lines, the points on the two lines will be equal. So you have infinite point of intersections for these two lines. They are same line. And the second method, what we could do is we could see the D1, D2, they are parallel. So we are going to prove how to prove they are parallel. We could do the cross product. So D1 cross with D2, because the D1 cross D2, the magnitude give you D1, D2, then cosine. Okay, it's a sine, sorry. Cross product is sine, dot product is cosine. So we are going to see the cross product to see if they are 0 or not. So for cross product is a sine. D1, D2, this is angle theta. So cross product, we need to find the height. So we find the area. So it will be the sine theta. And for the dot product is a projection on the D2. So it's adjacent, is cosine. Then dot product, cross product, we could find IJK. We find the magnitude. So this is a 2, so we don't have 3. This is a 2, -1, and -6, 3. So the k will be 0, 0 direction, okay? So we have 3 dimension, we could just add it up. So the k direction is 0, 0, is on the z equals 0 plane. So now we find the I direction is just times will give you 0, and the j direction is 2, 0, so we put I here, 2, -6, because it's 2, 0, 0 times 0 give you 0, so will be 0. Only the k direction will have this part. So 2 times 3 minus -6 times -1 give you 0. Then we know, okay, the magnitude will be 0. So give us the magnitude is 0, okay? change to the magnitude of it. So it's 0, then we know that is a cosine theta, the sine theta equals 0. Okay. So sine theta equals 0, then we solve for the theta, give us the 0. So at least these two will be parallel. So D1 is parallel with D2. Then we need to continue to find if they have one point they are same. So we could sub in one of the point to the equation and find out if they are same. So for example, from the B, if t equals -2, then we sub it back, you will find out the r equals 3, 4. So one point on both lines and they are parallel, it will give you the same line. So then this is second method. So it doesn't matter which method you do it, as long as you could prove you have infinite point of intersection, then you have the two lines same. So the second one we prove they are parallel and also they have one common point. So if they have one common point and parallel, so it will be the same line. This is how we do it. And this is a vector equation. And we are going to continue to see that it's not only vector equation, we want to find more form of the equation. So another form of equation, we call it parametric equations. So parametric equation is same as what we did here, but we use a t. So if we have r equals r0 plus td, then we want to expand it. So r is xy, r0 is x0, y0, and d equals d1, d2. We sub all this one in. We sub all this one in x direction, you will find out x equals x0 plus td1. So xy equals x0, y0 plus td1, d2. We expand it, you will find out x direction is x0 plus td1. And y direction, so x0 plus td1. And y direction is y0 plus td2. Then just write x component out is this one, y component out is the second one. So you will see from vector equation, you just write it as component vectors, then you are able to write parametric equations out. And same thing, we write t belongs all real numbers there. And after that, we are going to practice more examples on these parametric equations. So they are similar, but different format. This is kind of like component vectors. Okay. So next example, example 4. It asks you write the parametric equation for the equation determined in example 2. So example 2, we have this equation. So r equals 4, 1 plus t, 3, -6. So we copy it here. R equals 4, 1 plus t, 3, -6. So what we are going to do is just write the vector r in x and y, then write it in the x component, y component. So we are going to write it as x equals 4 plus 3 times t, y equals 1 minus, so 1 minus 6 times t, so x direction, y direction separately, and write t belongs all real numbers. Then it's done. So this is your parametric equations for a line. And we are going to, so this is a second form, and we have one more form of the equation of a line. Symmetric. To find the symmetric equation of a line, you take the parametric equations and solve each for t. So we are going to solve for t from these two. So the first one, we move the x 4 to other side. We have x minus 4 equals 3t. Then bring the 3 to other side. We have t equals x minus 4 over 3. Then continue for the y. Move the 1 to other side. Is opposite operation. Then move the negative 6 to other side. Is opposite operation is division. So we have t equals y minus 1 over negative 6. Then from these two equations, we want to write the left side equals. So x minus 4 over 3 equals y minus 1 over negative 6. So this is called a symmetric equation. And you may think it is a little bit overwhelmed, and you compare it with this one, you will see if this is x0, y0, this is our d1, d2, you will find out this 4 is our x minus x0. And this 1 is our y0, so y minus y0. And the two numbers below is our vector, direction vector, d1, d2. So this is x direction, this is y direction, this is a given point. And these two are the given direction vector. So this is r0, okay? So you just put the x0, y0 to the top and the direction vector at the bottom. You have the symmetric equation of a line. So this is the third form. You need to remember all these three type of forms of equation. So the first one is just the r equals r0 plus td. This is a vector equation. And the second one is just write x, y component out. X equals, we call it parametric equations. So x equals x0 plus td1. Y equals y0 plus td2. So just x, y component separate. Then the third form is just x minus x0 equals y minus y0 and divided by the direction vector. So now example 5, write the equation of line from example 2 in symmetric equation. So we are going to write it. X take away x0 is 4 divided by the direction vector equals y minus y0 divided by the y direction vector. So it's negative 6. Then it's done. This is how you do it, okay? So it's same as what we did here. Then example 6. So this one asks you to find the vector, equation, parametric, all the three forms of the equation of a line. And also this Cartesian equation is what we have done before, y equals mx plus b form, or the ax plus by plus c equals 0 form. We call this Cartesian equation of the vector that has a direction, this one, and pass a point. So this is our x0, y0 is our point, one point on the line, and this is our direction vector d1, d2. So vector equation is r equals r0 plus t times the direction vector. So we just sub in 3, 4 plus t 2, 1. Then it's done. The second one, parametric. Parametric equation is just x component, y component. So r is xy, so x equals x direction, 3 plus 2t. And the y equals, this r is xy, y equals y direction, 4 plus 1t, and the t belongs all real numbers. So here, same thing, t belongs all real numbers. So this is a parametric equation and symmetric. So symmetric equation is kind of like solve for the t. So x minus x0 equals y minus y0, and divide by the direction vector 2 and 1. This is our symmetric equation. And go back to our Cartesian equation. So for this one, what we could do is it's just from here cross multiply. Then simplify it. We can get our standard form of y equals mxb form. So cross multiply, we are going to have x minus 3 times 1 equals 2 times y minus 4. Expand, we have x minus 3 equals 2y minus 8. Then move everything to other side. If it's standard form, so x minus 2y negative 3 plus 8. X minus 2y plus 5 equals 0. So this is a standard form. We could just stop here. So 4 different formats. And you will see that vector equation give you the in vectors form. So, and if it's in 3 dimensions, this will be easier because we just extend it to z, another direction, then you will have 8 as an equation of a line in 3 dimensions. So example, next example, then convert a Cartesian equation to vector. So you need to be fluent to convert from one form to another form. So how to convert this one, we are going to see vector form. So vector equation. In vector equation, we know we need 1 point and also we need 1 direction vector. So we are going to just randomly pick 2 points. So let x equals 0. You could let x equals any other numbers, but we want to make it as easier as possible. I simply simple as possible. So we pick x equals 0. We have 2 times 0 minus 3y plus 6 equals 0. Then we could move the minus 3y to other side. It's positive 3y. 2 times 0 is 0. 0 plus 6 is 6. Then solve for y. We have y equals 2. So we have 1 point. This is our first point, R0. Then we could find another point. For another point, you could find the x equals 1 to find another point, or you could change it to the slope y-intercept form. So if we have mx plus b, then this m rise over run will give us a direction vector. So this is rise, this is run. Then the run comma rise is our direction vector. So this is what we want to use. Then we want to solve for y from this one. So this is a step 1. Find the 1 point on the line. And step 2, we want to find the slope. How to find the slope? We isolate y. So we could move the x and the 6 to other side. Minus 2x minus 6 and divided by negative 3. So we have y equals positive 2 over 3x, then plus 2. So negative 2 divided by negative 3, negative negative becomes positive. Negative 6 divided by negative 3 give you 2. So we want the slope. Then we have known that the rise is 2, run is 3. Then from the direction vector, it will be, this point will be 3, 2. Then we are able to write the vector equation is r equals 0, 2 plus t 3, 2. Then t belongs all real numbers. So this is for the vectors equation. Then we continue the parametric. So we have the vector equation. Parametric equation will be just the x component. So and y component, x direction, y direction. X direction is 0 plus 3 times t. And y direction is 2 plus 2 times t. And t belongs all real numbers. And the symmetric. Symmetric equation is just x minus the point 0, y minus the point at very beginning, then divide by the direction vector 3, 2. That equals, this is our symmetric equation. So that is done. And here is a summary. What we have covered in this lesson is vector equation of a line. So r equals r0 plus t times m, or t times d. D is just a direction vector. R0 is just a point on the line. The point on the line. And y0, okay. I will rewrite it. So it's just any point on the line. You could just if it's a Cartesian equation given, you just pick any x value, then find y value. That is your 1 point on the line. And the parametric equation is just x component write out, y component write out. And don't forget, t belongs all real numbers. And symmetric equation is just kind of solve for t, move the x0, y0 to other side, and bring the direction vector AB to the bottom. So Cartesian equation is just cross multiply, move everything to other side, then you have 0. Normally a need to be integer and positive. Okay, so that is all for today's lesson. Thanks for watching.